Hey there! In this video we're going to prepare our play-by-play data in a way so that we can build our own XG model. And then in the next video we're going to actually build the XG model. But before we get started, let's just look at what we already have, because in one of the previous videos we did a lot of data transformations on our play-by-play data. So let's just start off by selecting this table. So it's just select everything from play-by-play adjusted and semicolon. So let's just try and run this to see what we got. So we have already cleaned our play-by-play data quite a bit. So there's not too much to do in order to prepare our data to be built so that we can build the XG model. So the first thing we need to do is we need to just remove on shots. We're only interested in building our XG model based on on-block shot attempts. So whenever Fenwick is equal to 1, those are the events that we're going to include in our XG model. So let's just start off by doing that. So we'll just use the where function. So let's say where Fenwick equals 1. So now we are only including on-block shot attempts. So you can see the shot distance, the shot angle, those will be variables in our XG model. And then we also want to have time since last event, we want to have last event, we want to have score state, we want to have string state, and we want to have shot type as variables in our XG model. And for now, in this simple XG model, that's all we're going to include. But we do need to clean these a little bit up before we can build our XG model. So let's just do it one step at a time. So let's start with the string states. So we already have a column called string states, but in our XG model, especially because we're only using one season worth of data, we want to combine some of these string states so we'll put 5-on-3 together with 4-on-3. So that power play will be considered the same in terms of building our XG model, even though it's different to play 5-on-3 versus 4-on-3. But it is more similar to play 4-on-3 to 5-on-3 than it is to play 4-on-3 against 5-on-4, if that makes sense. So let's just start off by looking at the kind of string states that we have. So we'll say select distinct string state from play-by-play adjusted. So this just lists the different string states that we have in our table. So you can see at 1 against 0, that's penalty shots. We don't want to include those in our XG model. And then you have the empty net against. We also don't want to include those in our XG model because we will have to build an XG model specifically for the empty net shots. So these are the different string states that we have. So the first thing we can do is let's just ignore all empty net shots as well. So we'll just say we are only including events where string states is different from empty net against. So now we are excluding all empty net shots. Okay, so let's just try and build a case function. Use the case function to create a new string state column. Okay, so let's just say that when the string state is equal to 5 on 5, then we'll call it even strength 1. When string state equals 4 on 4, or string state equals 3 on 3, then we'll call it even strength 2. So I'm lumping together 4 on 4 and 3 on 3 because there's not a lot of data with 4 on 4, I suppose, because 3 on 3 is overtime. So I think it's better to just lump them together in this simple XG model. So let's do it like this and say then we'll call it even strength 2. And then we can write when, let's just go down a bit. So when string state is equal to 5 on 4, or string state is equal to empty net 4. So I'm lumping together 5 on 4 power play with 6 on 5 situations where one team has pulled the goalie. Then we'll count that as if it's a normal power play. Again, it's not perfect, but there's not that much data for 6 on 5 hockey when we're just looking at one season, so I prefer to do it this way. So let's call it, so let's say then we'll call it power play 1. And then we'll do the power play 2 as well. So when string state is equal to 4 on 3, or string state is equal to 5 on 3, then we'll call it PP2. Okay, and then we'll do the shorthanded. So when string state equals 4 on 5, or string state equals 3 on 4, or string state equals 3 on 5, then we'll call it shorthanded. Okay, so I think we have all of these now, except for the 1 against 0. But we'll actually ignore that one as well. So we'll go here and say when string state is equal to, has to be different. Oh, it has to be an and string state has to be different from blank, and string state has to be different from 1 on 0. So now we're just excluding all situations where it's against an empty net, where there's no string state. I don't know what this is actually, but I suppose it's just 1 or 2 events. And then we are also removing all 1 and zeros. So I don't think there is a string state blank when there is a shot actually. So I don't think we have to do it because I think it's already removed when we're only looking at Fenmix. But this way we're certain that we're removing those. Okay, so that's it. So now we can just end our case function and call it string state. Okay, so that was the first part. So now we adjusted our string state column. We'll do the same for the score state. So right now the score state goes from -10 perhaps, or -8 or something like that, all the way up to +8, +10, how far it goes. But we don't want to have that many different states. So we're just interested in looking at whether the team is leading by 1, leading by 2, or leading by more than 2. So we'll create a new case function and say case when score state is less than -2. So when a team is trailing by more than 2, then we'll call it, let's just call it less than -2. When score state is more than 2, then we'll call it more than 2. And else we'll just put in score state. So in every other instance, we're just going to use the same score state. So if it's 1, then it's just 1. And we'll end it here and call it score state. Okay. So now we got the string state and the score state correct. Then let's fix the last event, because I want to differentiate between whether or not the last event was a shot or the last event was a hit or a face-off or something like that. So basically I want to differentiate between, so I want to put events like shots and giveaways, takeaways in one category, and then all the others in another category. So let's just create yet another case function. Case when last event. Actually, let's just look up all of the different last event types here. So we'll select all the distinct last events. Let's try and run it. So you can see there is quite a few things here. So the ones that we are interested in specifying is the failed shot attempt, it's the missed shot, it's the shot on goal, block shot, and also giveaways and takeaways. Because my theory is that when you have a giveaway event or a takeaway event and then a shot shortly thereafter, then you have a larger chance of scoring. So that's the theory behind it. And the same thing, if you have a shot and then a rebound, then you're more likely to score. So we'll lump all of those together. So we'll just say last event equals giveaway or last event equals takeaway. last event equals shot on goal, or last event equals missed shot, or last event equals block shot, or last event equals failed shot, shot attempt, I think it is. Failed shot attempt, yeah. And I think that's it. So whenever it's one of these, then we'll call it, let's just call it shot. And I know some of these are takeaways and giveaways, but let's just put it in as a shot. If it's not that, then we'll say it's other. So we're putting the last event into two categories. Either it's a shot attempt or shot-like attempt, or it's something else, so it's other. But we are also not interested. So if you have a shot and then 20 seconds later have another shot, then we don't want the last event to play any kind of effect into the next shot. So we'll actually say when time since last event is more than 3, then we'll say, let's just say no. So then we'll say there is no last event, or we could say none or whatever. Let's say none actually. Because if it's more than 3 seconds ago, then I don't think the last event matters all that much. So we're only like accounting for last events whenever the last event happened less than 3 seconds ago. Okay, so we'll just end it here and say end as last event. Then we'll do the shot types. So let's just list up all the shot types here. So let's say shot type and run it. So we have wrist shots, tip-ins, snapshots, slap shots, pokes. So there are a few new ones here. So there are poke shots, there are batted shots, there are between the legs shots, and cradle. I don't even know what that is. But there's very few of these kind of shots, so we'll just lump these together and call them all other. I suppose maybe some of them has a higher goal probability. I don't know actually, but we'll just lump them all together now and call it other. So we'll make our last case function. So when shot type equals so let's say bat or shot type equals between legs or shot type equals poke or shot type equals cradle. for shot type is blank. So I think those are the special ones. So in that case, we'll call it other. Else we'll just put in the shot type. And then we'll end the case function and say as shot type. And then that's it actually. So now we don't want to do any more adjustments. We just want to put it in there. But we don't need to have all of the columns. We just need these new case columns here. And we need the shot distance and we need the shot angle because those will also be variables in our XG model. And then we'll just put in the event ID also so that we can go back and find the correct event. So we'll say event ID. We'll say shot distance. We'll say shot angle. And then we'll put in our case functions here. And then in the very end, we'll put in a column with the goals because we need to have the actual goals so that we can compare our XG model with the actual goals. So let's try and run this, and I think it should work. So now we have a table with all on-block shot attempts except for empty net situations and penalty shots. And we do have the score state in different categories. We do have the last event if the last event is within 3 seconds of the current event. And then we do have the shot type and we have whether or not the shot was a goal. So this is all we're going to need when we want to build our XG model. So this will be a relatively simple model, but it does work. So let's just create a table. We can call it XG model. Yeah, let's just call it XG model actually. So let's try and create this. And you can see here that there are 120,000 shots in the 23-24 season. So those are the shot attempts that we're going to build our XG model based on. If you're going to build your own XG model, I would probably prefer using more than just one season to train the model, but we'll just use one season in this tutorial. So the very last thing we need to do is we need to just save this table here as a CSV file, and then we'll do the modeling in Python in the next video. So we can write to CSV from MySQL using the into-out file function. So now we've created the model, so we can just say select everything from XG model into out file and then we need to call it something, so we'll just call it XG model.csv. And I think we need to put this in like this, so it's a text. And then we need to define how it's terminated, so we'll just say terminated by comma, so it's comma separated values. And that should be it, I think. So let's try and run this. Select everything from not terminated by, but it has to be fields terminated by a comma. So let's try and run this. And you can see now it's written it. So we need to go find it. So it's in the program data, and this one is hidden. So you need to unhide it, but I have it unhidden already. And then you need to go to MySQL, server, data, and then the database, is called YouTube. So we'll go to YouTube. And now you can see there is a file here, a CSV file, and that's it. So let's just try and open it. And we do have all of the columns, we do have all of the data here, but there is no headers. So when you're writing from MySQL to CSV, then it doesn't include the headers. So we can either load this into Python and then add the headers, or we can do it directly in MySQL. So let's just do the last one. But we have saved as a CSV file now. So let's just say, let's delete this one. And then try and add a header. So we'll just go here and say, let's clean it up a little bit. Into out file, fields terminated by comma. Okay, so we need to add a header and then do a union with the rest. So all we have to do is we have to say select and then we just need to put in the names of our columns. So it's event ID. So now it should work. And then we can go and open the file here. And there should be a header now. And you can see there is. So this is short distance, short angle, string state, and so on. So this table right here is all we're going to need in order to build our XG model. But we'll do that in the next video. So I don't actually want to include anything more in this video. This is how we prepared the data so that in the next video we can build our XG model, and we just wrote our table into a CSV file because we are going to need that CSV file to model our data, but we'll do that in the next video. So there's nothing more in this video, so see you next time.